How's everyone doing today? Mr. Pettis, your favorite Algebra 2 teacher. What we're going to go over today is solving exponential equations using the same basis. So this will be the easy part. Tomorrow will be a little bit more complex. We're going to go over three properties first. The first property is your zero property. And what that means is anything to the zero power equals 1. X to the zero power is going to be 1. 5 to the zero power is going to equal 1. Negative 17 to the zero power will be 1. So the zero property is anything to the zero power equals 1. Now the negative power or negative property. You know this already. We've done this before. They might just look a little bit different. But when you have a negative power, it's going to make you the inverse fraction. Okay, so if you have a negative power, it's going to be the same power, but it has to be on the denominator. So it's going to be 1 over. So if this is x to the negative 4, this is going to be 1x to the 4th. So you can never have a negative power. If you do, you have to change it to a fraction, and the power becomes positive. Okay, and then the power property is when you have two powers side by side like this, well then you actually do multiply. Okay, so if this was 2 and this was 5, this would be 10, because you actually do multiply the exponents only when they're both exponents outside each other with the parentheses. Okay, so we'll use some of those in the examples here. So example number 1, 3x to the negative 4 or x minus 4 power equals 27. So you can solve this, but you have to know you need these to both be the same base. So when I'm looking at this, I'm looking at what is 3 or what is 27 with 3 being the base. What I mean is if I have 3 to the first power, I know that equals 3. If I have 3 to the second power, I know that equals 9. So if I have 3 to the third power, that is going to be my 27. So we want the base, which is a big number, to be the same. So this 27 is equivalent to 3 to the third power. The left side stays the same. And what happens is you just drop the bases. So my problem becomes x minus 4 equals 3. This 3 up here. So you have the powers, okay? And then you just solve. So here x equals 7 because we add 4. And then you check your work, and that comes out to be true. Okay, so that's the same basis. All right, let's see what happens when we have a power already here, like with the 27. So say if we had 4, 3x minus 4 equals 8. All right, so both of these are not the same. Now, the smaller number 4, we could make it can't become 8. Like, you have to think of your squares. So 4 to the first equals 4. 4 squared equals 16, right? So 16 looks good, but we're dealing with powers now. If we do 8 to the first, we know it's 8. If we do 8 squared, that's already 64. Our number is going to be humongous if we keep on going this route, right? So we don't want to do that. What I want to do is you can actually make these smaller bases. Think of the smaller numbers first between trying to make this one to be a base of 4, which is not going to happen here, okay? You're going to make it too big, too big. So think of a smaller number like 2. Well, 2 squared is actually 4, right? 2 times 2 is 4. So then I keep the 3x minus 4 the same. And then think about 8. If I want the base to be 2, 2 to what power gives me 8? Okay, so that's going to be 3. So these equal each other here. They have the same base. You don't always have to go to the bigger number. If they have a smaller base in common, do that. So 2 works because 2 to the first is 2, 2 to the second is 4, and 2 to the third is 8. Boom, right there. That's what we wanted. That's what we started with, 4 and 8. So we're going to go smaller. Perfect. So you have the same base. Go ahead and drop the bases. So drop the power The bases cancel out. Just drop your power. And then go ahead and solve for that. So distribute the 2. And then just reverse PEMDAS. Add the 8. So that's 11. Divide by 6. We get a fraction. 11 over 6. Go ahead and check your work. It'll come out to be true. Okay? Alright, so let's do one more on this side. Let's do 4x plus 1 equals 1 over 64. Alright? So what do we need to do? Well, my smaller number's 4. So can I get 64 to be a power of 4? Or a base of 4? Well, over here we stopped at 2. I could do 4 to the 3rd, which does equal 64. Okay? So we could have used 4, 3, 8, 2, but those bases are not the same. So 2 was a better answer for this one. But now we have 64. If I do my 4s, I get to 64. So this guy here, I'm going to write it off to the side. 1 over 64 is the same as 1 over 4 to the 3rd. This is a fraction, this is not. Okay, this is where we're going to use our negative property. If we have a fraction, I know that this power should be negative. So I'm going to switch it around, and that's okay. 4 to negative 3. We want the bases to be the same. It's better to switch this one to a negative power than to switch this to a fraction. It's going to get crazy. I don't want to deal with fractions, okay? I know you don't. So 4x plus 1 is going to equal 4 to the negative 3 power. Boom. Base of 4, base of 4. Drop the bases, or cancel the bases and drop your power. And then go ahead and solve. X equals negative 4. And right there you could check. If I plug in negative 4 here, I get negative 3. Well, we already know it should be negative 3, so it's right. Okay, last one. So the last example is going to be one where you use the identity of 0. So for example, 7, 5x minus 2 equals 1. I love when you have 1. You should love when you have 1, because 1's your wild card. 1, x to the 0 power equals 1. That's your wild card. X is your wild card. You can make it anything. So if this is 7, what are we going to make this? 7. 7 to the power of 0 is still going to be 1. So when you get this, you should love those problems. It's just going to be that simple. So this is going to be 7 to the 0 power. Bases are the same, so just drop your power down. Drop your power. And go ahead and solve. So 5x equals 2, x equals 2 over 5. You could go ahead and plug it into your calculator, check true or false. It should come out as true. Sorry, I tried to beat the bell. Almost. Alright guys and girls, well that's it. You have a few problems in Google Classroom. Go ahead and work those out. Turn them in when you can. If you need help, come to tutoring, ask me for help. Mr. Pettis signing out. Like, subscribe. I'll see you on class.